What if I told you that OpenAI just got a serious competitor? And it's not just cheaper, but open source. DeepSeek R1 is here to disrupt the AI game, challenging the big players with insane reasoning power and game-changing pricing. Is this the future of AI or a threat to the industry? Let's find out. Imagine an AI that doesn't just give answers, but shows you how it thinks, step by step, like solving a puzzle. Meet DeepSeek R1, the open-source game-changer that's redefining how AI tackles complex problems. In this video, we'll uncover its unique approach, from chain-of-thought reasoning to cost-effective innovation, and explore how it might just shape the future of AI. We'll also discuss the implications of open-sourcing such powerful AI models and how they can shape the future of AI research and development. DeepSeek R1 packs several standout features. Open-source power. Modify, distribute, accept, and adapt the model to suit your needs. This fosters a collaborative community where innovation thrives. Cost-effective. With pricing 95% lower than competitors, it offers cutting-edge performance without breaking the bank. Scalable and flexible. From personal devices to enterprise servers, DeepSeek R1 adapts seamlessly. Diverse training data, built on a wide range of datasets to ensure unbiased and accurate outputs. These features make DeepSeek R1 a go-to choice for developers and researchers alike. Furthermore, DeepSeek R1 excels in chain-of-thought reasoning. This capability enables the model to tackle complex tasks by breaking them down into a series of smaller, more manageable steps. This approach significantly improves its ability to handle challenging queries and produce more accurate and insightful results. DeepSeek R1 is also designed with competitive pricing in mind. It aims to offer comparable or even superior performance to commercial models from companies like OpenAI, but at a more accessible price point. This makes it a more cost-effective option for developers and businesses looking to leverage the power of advanced AI. Scalability is another key feature of DeepSeek R1. It is designed to be deployed across a wide range of applications and environments, from small-scale devices to large-scale server setups. This flexibility allows users to adapt the model to their specific needs and resources. To facilitate easy integration, DeepSeek R1 provides a user-friendly API. This API simplifies the process of incorporating the model into various applications and systems, making it more accessible for developers with different levels of expertise. DeepSeek R1 has been trained on a diverse range of datasets. This extensive training helps to improve the model's accuracy and reduce biases in its responses, leading to more reliable and trustworthy outputs. Finally, DeepSeek R1 thrives on community involvement. As an open-source project, it encourages contributions from a wide range of users. This community-driven approach allows for continuous refinement and improvement of the model, ensuring it remains at the forefront of AI technology. These features make DeepSeek R1 a compelling option for developers and researchers seeking to leverage advanced AI capabilities without the high costs associated with proprietary models. DeepSeek R1 and OpenAI models present distinct approaches to large language models. Reasoning capabilities. Both models exhibit complex reasoning capabilities, although their effectiveness can vary depending on the specific model and the context of the query. Deployment. The open-source nature of DeepSeek R1 provides more flexible deployment options. OpenAI models often require cloud-based deployment through APIs, which can potentially introduce latency issues depending on the application's requirements. Think of chain-of-thought reasoning like assembling a Lego set. Instead of jumping straight to the finished model, the AI carefully follows the instructions step by step. This method not only ensures accuracy, but also lets you see the process unfold. Perfect for solving multi-step problems, just like humans do. Here are key aspects of chain-of-thought reasoning, step-by-step breakdown. Instead of immediately jumping to a final answer, the model generates intermediate reasoning steps. This systematic approach not only clarifies the model's thought process, but also increases the likelihood of arriving at accurate conclusions. Improved accuracy. By meticulously outlining each logical step, the model can effectively verify the validity of its reasoning at each stage. This rigorous self-checking significantly enhances accuracy, especially when dealing with complex tasks. Transparency. Chain-of-thought reasoning provides valuable insights into the model's decision-making process. Users can readily observe the reasoning sequence, fostering trust and improving the interpretability of the model's outputs. Diverse applications. This reasoning technique finds applications across various domains, including mathematical problem solving, logical reasoning, and natural language understanding tasks where nuanced interpretations and contextual awareness are crucial. Training and development. AI models can be specifically trained to incorporate chain-of-thought reasoning. This involves training them on examples that demonstrate multi-step reasoning, enabling the models to learn from structured prompts and queries. Consider a simple scenario. What is the total cost if I buy 3 apples at $2 each and 2 oranges at $1.50 each? A model employing chain-of-thought reasoning would approach this as follows. Calculate the cost of the apples. 3 apples, $2 apple, $6. Calculate the cost of the oranges. 2 oranges, $1.50, $3. Calculate the total cost. $6 for apples plus $3 for oranges equals $9. This structured approach demonstrates how chain-of-thought reasoning enhances the model's clarity and effectiveness, particularly when tackling more complex and intricate problems. DeepSeek R1 excelled in several performance benchmarks. Math reasoning scored 97.3% on the Math 500 benchmark, setting a record. Coding skills ranked in the 96.3rd percentile on the Codeforces benchmark, closely following OpenAI's 96.4th percentile. Slightly surpassed OpenAI's O1-1217 model with O1-1217 model with a pass at 1 score of compared to 79.2%. General knowledge scored lower than O1-1217 on MMLU, 90.8% versus 91.8%, and GPQA Diamond, 71.5% versus 75.7%, highlighting strengths in reasoning over knowledge retrieval. Software engineering achieved 49.2% on the SWE Bench Verified benchmark, indicating strong software verification performance. Alpaca Eval 2.0 won 87.6% of evaluations, demonstrating its ability to produce high-quality human-like text. DeepSeek R1 is highly cost-effective, with training costs 95% lower than competitors and an API priced at just 55 cents per million tokens, only 2% of OpenAI O1's cost. This disruptive pricing makes reasoning models accessible to most businesses. Additionally, DeepSeek R1 offers distilled models with comparable reasoning capabilities that run on smaller hardware, akin to an O1 Mini on your computer. They provide a range of distilled models from 1.5B to 70B parameters that can deliver GPT-4 level performance on customer GPUs. The technical architecture of DeepSeek R1 is impressive, utilizing a mixture of experts MOE setup with a total of 671 billion parameters, of which only 37 billion are activated per task. This design allows for efficient operation without sacrificing performance, as it leverages specialized parameters for specific tasks. DeepSeek R1's training approach is innovative. Unlike most LLMs that primarily use supervised fine-tuning (SFT), it emphasizes reinforcement learning (RL) with minimal SFT. DeepSeek R1 0. The model is trained solely with RL, enabling it to autonomously learn complex reasoning skills like self-verification and chain-of-thought (COAT) reasoning. DeepSeek R1, enhanced from R1 0 using a curated cold start dataset and multi-stage RL to improve readability and address language mixing issues. JARCO, a new algorithm that allows the model to generate multiple responses, evaluate them for accuracy and format, and reinforce the best results. Both DeepSeek R1 and OpenAI models present a variety of unique strengths and advantages that cater to different user preferences and requirements. For users who place a high value on customization options and seek a balance between performance and affordability, DeepSeek R1 may be particularly appealing. It allows for adjustments that can fit specific needs and budgets, making it an attractive choice for individuals and organizations alike. On the other hand, OpenAI models might attract those who are looking for a solution that offers robust, reliable support along with impressive out-of-the-box functionality. This distinction points to the idea that the best choice for any user will ultimately depend on their particular needs, preferences, and the resources available to them or their organization. DeepSeek R1 represents a noteworthy advancement in the realm of open-source artificial intelligence. It showcases significant improvements in reasoning efficiency, enhanced problem-solving capabilities, and overall cost-effectiveness. Moreover, it serves as a more accessible and viable alternative to the proprietary models developed by major technology companies. With its remarkable performance characteristics, DeepSeek R1 challenges the traditional paradigm characterized by resource-intensive development processes of closed models. This shift emphasizes the potential for innovation outside the conventional boundaries set by larger corporations. DeepSeek R1 isn't just another AI, it's a revolution in how we approach artificial intelligence. With its affordability, adaptability, and game-changing features like chain-of-thought reasoning, it's proving that innovation doesn't have to come with a premium price tag or closed door. What do you think? Could DeepSeek R1 redefine the AI landscape? Share your thoughts in the comments below. And if you enjoyed this deep dive into tech breakthroughs, make sure to like, subscribe, and hit that notification bell. Thanks for watching, and we'll see you in the next one.